Okay. Assalamualaikum and a very good morning to all of you. Today, I will share with you how to design a column. Okay, before start, let's doa first. Okay, Bismillahirrahmanirrahim. Allahumma ta'alina hikmataka wa syul alaina min khazain rahmatika li arhamir rahimin. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Okay. So last week we just go to beam design. Okay. Now we continue to column design. Okay. So after my sharing, I hope all of you can differentiate between short and slender column. Okay. Second, you can differentiate between braced and unbraced column. Then our main objective for design, still remember, is to calculate the area of reinforcement bar because we will propose diameter and number of reinforcement bar. Then we will calculate links and sketch cross-sectional of column details including the link. Okay. Here is the load parts of building. Okay, the load parts of building. As you can see here, the top one is a slab. Okay, slab floor, lantai. Okay, slab will distribute its load to beam. Okay, slab will distribute load to beam. Then beam will distribute load to column. Okay, here column as a vertical compression member which support beam will transmit the load to the foundation. Okay, you see the arrow. Then the foundation will transmit or will distribute load to the surrounding. Okay, here the foundation will distribute load to the ground. Okay, guys. Okay, just now we have our first and second outcome is differentiate between short column and slender column, and also differentiate between braced column and unbraced column, right? So first we see the differences between short column and long column. Long column also known as slender column. Okay, tiang pendek, tiang panjang or tiang langsing. Slender is langsing. Okay, these two types of column, okay, we will differentiate between which one is short column, which one is slender column based on slenderness ratio. Slenderness ratio state the effective length divided by least column dimension more than 12 is a slender column. While if the ratio of effective length divided by least column dimension less than or equal to 12, that one is short column. Here is the example of slender column. Okay, slender column. And this one is a short column. Okay. Here we have 6 differences between short and slender column. Short column, just now, the ratio of effective length to its least lateral dimension is less than 12. For slender column, the ratio of effective length to its least lateral dimension is greater than 12. Okay, I will show you this part. Okay, how to determine either that column is short or slender. Okay, lateral dimension is very large when compared to its length for short. Means the cross section of column for short column. Okay, lateral dimension, the cross section is very large when compared to its length. Okay, very large when compared to its length. While the slenderness column, the lateral dimension is very small when compared to its length. Okay, for short column, the failure mode of short column is a crash, pecah, okay, crash. While for slender is buckling, is buckle, melentur, okay, bending, okay, bend, buckle. Okay, so short column is subjected to compressive stress, while slender column is subjected to buckling stress. So short column, the buckling tendency is very low. Short column can't buckle because it's short, so it will crash. Okay, it will crash. While the slender column will buckle because it's a thin column. Okay, thin and long column. And short column, the load carrying capacity is more than the load carrying capacity for slender column. So you have to remember all these 6 comparison between short and slender column. Okay, this diagram show compression failure. Compression failure refer to crushing failure for short column. Okay, as you can see, this column can't withstand the load applied on it. Okay, this column can't withstand the load applied on it, so it will crash for short column. Okay, then this is the buckling failure for slender column. Here you see the reinforcement bar, it buckle, it bend. Okay, it bend from the side. Okay, from the side. Okay, I show you how to differentiate, how to determine either that column is short or slender. Okay, for example, we have one, sorry. Okay. For example, we have one column. Okay, we column here. We don't know either this column is short or slender. Okay, so the actual length of this column is 6 meter. Okay, this size 0.3 meter. Width that is 0.4 meter. Okay, so this column, okay, how to identify either this column is short or slender? It depends on the types of support. Okay, the types of support. Here we have one fixed end, one free end. Okay, and this one is both support. Okay, both ends are supported by pin. Both end AB supported by one fixed, one pin, and for this column, and support is fixed. Both and support is fixed support. So I will use this. Okay, I will use this part. So let's say here we have one column and support is pin. Okay, supported by fixed support. So the actual length this now is 6 meter. So we know after we apply load for fixed support, for both and fixed support, this column will buckle at this center part. Okay, so the effective length, the buckle length, or effective length is equal to 0.5 L. Okay, here we take this support and support. So how to identify either this column is short or slender column? So we use the slenderness ratio. So ratio equal to effective length divided by least dimension, lateral least dimension. Okay, lateral least dimension refer to the cross section dimension. Okay, effective length, we take both end fixed, right? So 0.5 L. Effective length is 0.5 from actual length is 6 meter times 6 divided by least dimension. Between 0.3 and 0.4, the last one is 0.3, right? So right by 0.3. So here we have 0.3, sorry. So here we have 3 divided by 0.3. So the answer is 10. So we know 10 is less than 12. So this column is a short column. Why? Because the slenderness ratio is less than 12. Okay? What the important here is you have to know that you have to be familiar with this comparison between short and slender column. I just show you how to differentiate. Okay, how to determine between either this column is short or slender. Then for second learning outcome, you have to know how to differentiate between brace and unbraced column. What is braced column? See, here we have from plan view. Okay, from plan view, we have a shear wall here, shear wall, brick wall. Okay, brick wall here, left and right. Then we have a column. This one is a column. Okay, we have column in this area. So this y-axis, x-axis. Instead here, column brace in y direction. What is mean by brace column? Brace column occur when lateral loads are resisted by shear wall or bracing rather than by column. Okay, column brace in y direction. You see, in y direction ni, okay, shear wall located in y direction, right? Shear wall located in y direction. So in y direction, the column are braced. The column are braced. Because of what? Lateral load. Okay, lateral load, for example, here lateral load. Example of lateral load is wind, earthquake, okay, like a wind or earthquake. So when wind come from this side, so it will have shear wall to prevent it. Okay. So the brace column is when the lateral load, okay, when the lateral load are resisted by the shear wall, okay, by the shear wall or bracing, whether the column, okay. And unbraced column will occur in x direction. You see, in x direction here, x direction, there is no shear wall. There is no shear wall in x direction. So in x direction, the column are unbraced. The columns are unbraced. So here, lateral load, let's say there is a wind from here. Okay, there is a wind from here. So the wind or lateral loads are resisted by the sway action of column. The wind will resisted by the column itself. Okay, because there is no shear wall here. So column braced in y direction, unbraced in x direction. Okay, next figure we have column brace in both direction. Okay, column brace in y direction and also in x direction. Because of what? In x direction, you see in x direction, okay, in x direction we have this shear wall. Okay, we have this shear wall in x direction. And in y direction, we have this shear wall in y direction. Okay, so both direction are brace column. Okay, guys? So what are differences between brace and unbraced column? Just now I said to you, for brace column, lateral strength or lateral load arranged as a whole is arranged with walls or bracing. So lateral load will resisted by wall or bracing for bracing. But for unbraced column, the lateral strength will resisted by column only. Okay, totally on column. Brace column can't withstand lateral load. Okay, brace column can't withstand lateral load. That's why we have shear wall and bracing. Okay, so let's say we have here column and we have a bracing here. So can't withstand lateral load. So brace column can't withstand lateral load. So that's why we install the shear wall or bracing on it. Okay, for unbraced column, Unbraced column can withstand the lateral load. So that's why we don't have to install the bracing or shear wall. Okay, can withstand lateral load for unbraced column. Okay. In braced frame, lateral load like wind, etc., resisted by some special arrangement, just now like shear wall, bracing, or special support. Hence, the column size can be optimized. So here, the lateral load will support by shear wall or bracing, right? So the size of for brace column. So for brace column, the column size, okay, the column size can be optimized because of what? Shear wall and bracing will help column to support the lateral loads applied on it. While for unbraced column, okay, unbraced column, here it said what? Lateral loads like wind, earthquake, etc. are resisted by column or which make column heavy and large size. So for unbraced column, okay, so for unbraced column, we have to make the column heavy and large size because totally the lateral load will support by the column. Okay, so braced column have zero value of sway. So braced column cannot sway, because it varies rigid. Okay, it's very rigid with the bracing. But unbraced column are subjected to sway. So unbraced column easy to sway because there is no bracing to support the, okay, easy to sway. Okay, there is no bracing to support the column, so it easy to sway. Structure system has bracing are mostly used in important or special structures, high-rise building. So we use brace column in high-rise building or tall building, but for unbraced column always apply on normal low-rise structure. Okay, brace column mainly used to design the steel structure, but for design in reinforced concrete, we use unbraced column. Okay, guys. So you have to remember all these six, the comparison between braced and unbraced column. Okay, next we go to reinforcement detail. Okay, reinforcement detail in reinforced concrete column. Okay, reinforced concrete column. The minimum bar required in column is 4. Okay, the minimum bar required in column are 4 bar for rectangular or square column. While for circular column, okay, column bulat. So the minimum bar is 6. Okay, and the size, minimum size of bar is 10 millimeter. Okay, 10 millimeter. That one the requirement for main bar. Okay, then we have link, right? We have link. So minimum size for link is 1/4 of size of the largest compression bar. Means minimum size of link, diameter link lah. Okay, diameter link equal to 1/4 of diameter main bar. Okay, but not less than 6 millimeter. Okay, the minimum size of link is 6 millimeter lah. Okay, then maximum spacing. Maximum spacing is 12 times the diameter of the smallest longitudinal bar or the smallest cross sectional. Here spacing of link equal to 12 times diameter of main bar. Okay, we will do some exercise for this design. Okay, guys? Okay, here we have the cross sectional. Here is the rectangular type beam, type column, or rectangular or square column. Here we have spiral or circular column. So this is a cross section. Okay, this is a cross section of column. Cross section of column. So what you have in column? Okay, you have a concrete here, concrete. Okay, here is the what? We import concrete cover, right? So here is concrete cover. Then we have reinforcement bar. Then we have reinforcement bar. Okay, sorry, reinforcement bar here. Okay, then we have reinforcement bar. And also we have link, right? Link. So in sketching cross section, you have to sketch like this. Okay, we have a concrete cover, we have link surrounding the reinforcement bar, and don't forget to make the curve one falling as a band. Okay, here is the 3D view. 3D view for 3D view for reinforced concrete column. Okay, spacing of link means here you have to find the distance between two link. The distance between each link. Okay, here equal to what? 12D, right? Okay, so we will design only rectangular or square column. Okay, here we have short axially loaded column design. Okay, short axially loaded column design. We will focus on design short, okay, yang pendek. Axially loaded means we apply load on the eccentric of column cross section. And the equation given is n equal to 0.4 FCU A area of concrete plus 0.8 Fy AS. Okay, n is ultimate axial load. Okay, n is ultimate axial load. This ultimate axial load means this is a design load. Okay, ultimate axial load. Normally given in unit kilonewton. Okay, given in unit kilonewton. And here we have FCU. Okay, 0.4 FCU. FCU is concrete strength. Okay, concrete strength. Area of concrete. Okay, area of concrete here. Okay, area of concrete. How to determine area of concrete? Let's say here we have the size of our size of square column is 200 times 200. So area of concrete. Don't forget, we design reinforced concrete, right? So in our column have a reinforcement. Okay, in our column have a reinforcement, right? So area of concrete means, okay, area of concrete. So AC, area of concrete equal to 200 times 200 minus AS. Why? Because here we have a total area of reinforcement, right? So 200 times 200 minus total area of reinforcement bar. This one is for area of concrete. And then we have plus 0.8. Fy is still reinforcement strength or steel strength, and AS is area of reinforcement. Okay, area of reinforcement, total area of reinforcement. Okay, look, let's do the exercise. Here we have a question, a short column. Okay, a short column having a square cross section 350. Okay, let's say we sketch the cross section. Okay, here we have a cross section of column. Okay, the size is 350. Okay, to resist an ultimate axial load of 3000 kilonewton. Okay, so we apply axial load 3000 kilonewton. Okay, At the same time, the steel yields at the corresponding stress level of 0.4 FCU, 0.8 FY respectively. Okay, you see you just given the concrete stress and tension stress, right? So you have to remember, here already given the formula. So N equal to 0.4 FCU AC plus 0.8 FY ASC, where AC is net area of concrete. Okay, net area of concrete. FCU given is 35 Newton per millimeter square and FY given is 460 Newton per millimeter square. So first we will calculate the area. Okay, we will calculate the area. Then we will determine the minimum diameter of bar if the column is to be reinforced with 4 number. So if we have 4 number of bar, so what is the diameter of bar? And we also will calculate the link. Okay, we will calculate the link, means we will find out the diameter of link and also the spacing of link here. And the last one, we will sketch cross-sectional details of column including links. Okay, we do the first one. Okay, remember we have a formula N equal to 0.4 FCU, net area of concrete, plus 0.8 FY, total area of reinforcement AS. So N given in kilonewton. Okay, please be careful. FCU is in Newton per millimeter square. Unit Newton, right? So here we convert kilonewton to Newton. So 3010 times 10 the power of 3 equal to 0.4 FCU 35 given AC. Okay, net area of concrete is 350. Okay, 350 square minus AS plus 0.8 FY given 460. AS is total area of reinforcement. So from this, we will get AS equal to 3630 millimeter square. Sorry, it should be like this. Okay, so 3630 millimeter square. D is total area, right? Okay, D is total area. For how many bar? For 4 bar. Okay, for 4 bar. So area for 1 bar is 3630 divided by 4, we get 907.5 millimeter square. Okay guys? Okay. So what are we going to determine minimum diameter? Okay, diameter. So formula for area equal to pi d square over 4, right? Okay, so area for 1 bar is 907.5. So here we will get the diameter. Size is 40. Okay, diameter size is 40. So your final answer is 40 for 40. 40. 4 refer to number of bar. T refer to HIG. Okay. T refer to high tensile steel. Okay, high tensile steel used. And 40 refer to diameter of bar. Okay, your final answer should be like this. 40, 40, 40. Okay. So next question is we calculate the diameter of link and also the spacing. So diameter and spacing for link very easy. We just substitute in the formula. Okay, 1/4 times diameter. Okay, we get the diameter of main bar is 40. So 1/4 times 40, we get 10. Okay, the minimum diameter for link is 6, right? So 10 accepted. Then spacing is 12D. Okay, diameter. So 12 times 40, we get 480 millimeter. So your final answer is provide T10 links at 480 millimeter center to center. Okay guys, so we just complete 3 questions. And next is cross-section details. Okay, cross-section detail for the last question, right? So cross-section detail, I just said just now. Okay, draw the square column 350. Okay, label it. Sketching with label. Okay, remember sketching with label. So you sketch. Okay, then label the dimension 350 times 350. Then you have 4 main bar. For main bar, size is 40. Then we have link here. Our link size is T10. And don't forget to make the link bend here. Okay, bend here. And you can also label the what here is the concrete cover. Okay. So guys, that's all for column design. Okay, for column design, what you have to be familiar with is the formula. Okay, with this formula, you have to be familiar with this formula and know how to substitute the value. Okay, substitute the value. Okay, we find out the area of steel, the diameter of steel. Okay, number of steel given, link, diameter link, and spacing, and also sketching the cross section tape. Okay, that's all for column design. Thank you from me. Assalamualaikum. Zack and podcast habis dah kan? Habis dah kan? Tekan and podcast habis dah kan? So dia tak mau ni. And apa? Dak ni tekan and podcast dia tak mau. And apa? Dak ni nak tekan and podcast ni. Dia tak mau.
Dah habis ke?
Dah. Dia tak mau lagi. Siapa? Siapa?
Ni buka